I think, okay. So is it visible? The slides are visible?
Yes, sir.
Okay, thank you so much. Okay, so this is where actually, yes, this is where actually we stopped during the last break, right? So, but ultimately, we are more worried about the future, right? So, why this data is getting so much of voluminous, right? So, and who are creating this data and how to handle this data, right? So, all these things we'll try to discuss in the present session. Right. So see, this is what it trends. See, the digital universe is growing almost in 50 folds. Right. So in 50 folds, and you can see this statistics. So what type of graph it is? What type of graph it is? If you see from 2005 to 2020, it is just hardly 15 years time. Right. So it is hardly 15 years of time. And approximately around 1 ZB, that is zettabytes of data has been generated. Right. So what is this type of the graph you are seeing? What type of graph it is?
It is an exponential graph.
Right. So it is an exponential graph, right? So it is an exponential graph, and every day, right? So the data is getting added and added and added. See, a good example that can be given is as just now, as soon as I started this session, HRDC office has started recording this, session. Right. So if the HRDC is recording this session, obviously that whatever we discuss for 2 hours of time, right? So 2 hours of time or 2.5 hours of time, right? So automatically it will be stored in the some space, right? So it automatically it will be stored in some of the databases. Now the big question is how to manage these kind of an data, right? So how to manage these kind of an data is a big challenging task, right? So that we'll see like how to do it, right? So see, we slowly started with the 1 gigabyte of data, right? So 1 gigabyte of data, and then we slowly moved to terabyte of data, and then we moved to petabyte of data, and then exabyte of data, and then now we are in the we are in the period of zeta bytes, right? So, but now there is a very interesting thing that you can see in the slide. Right, so there are blue lines, right? So there are blue lines and there are red lines, right? So and there are red lines. So what are these blue lines and the red lines, right? So the combination, right? So it says this data is structured and the data is unstructured, right? So can anyone tell what is structured data and unstructured data? Any guess at least? Not the exact definition I'm expecting, but at least any guess.
Systematically presented.
Okay, systematic. Some data which is presented in a very systematic way is called as a structured data. Agree. Unstructured, as such, there is no any
raw data.
As such, there is no any systemic structure that we are going to maintain. A good example that can be given is if you see the table, right? So if you see the table, right? So you will store serial number 1, right? So name Kariguli, Dr. Kariguli is designation associate professor or professor, is degree PhD, is domain so and so, number of students guiding, number of students research scholars awarded, a number of papers published in conference, number of papers published in journals, number of projects awarded, number of projects submitted. So that is, don't you think that's a very structured way of presenting the content? Right. So that table itself is a very good example, right? So that can be considered, right? So that can be considered, right? So in order to say that the data is stored in a very structured way, but that is not a big deal to handle because more or less a simple instruction can be given, right? So instruction means if you talk from the perspective of computer science, right? So it is basically a small program that you are going to write, right? It's a small program that you can write, and that small program is more than enough to handle this table because there is a serial number, right? So that is given for each data, right? So you'll be handling only the row versus column. For example, the first row contains Dr. Kariguli information and so many number of columns. The second row contains Dr. Vani Madam's information, so many number of columns. Third row contains Dr. Kausar, information, right? So the same set of an information, right? So ultimately, that is what the structure that we are going to give. But that handling that kind of a structured tabular data is very easy when compared to the data which are of unstructured in nature, right? So which are of unstructured in nature. Now we need to come out with a mechanism, right? So we need to come out with a mechanism such that these unstructured data should be handled in a very effective way. For example, some of the information is given in some of the information pertaining to Dr. Kariguli is given and some of the information is not given. But in Dr. Dr. Vani Madam case, some information that are given by Dr. Kariguli is not given by Dr. Vani Madam and some information given by Dr. Vani Madam is not given by Dr. Kariguli. Right. So then the entire tabular kind of a structure, right? So we'll have totally an imbalance, right? So totally we'll have totally an imbalance, right? So yes, that kind of a data is called as an unstructured data, right? So that is why it's not only the challenges lies with only handling the voluminous of the data, but the challenge lies in handling the unstructured data also, right? So an unstructured data also. A simple example that can be given, right? So especially, in your own domains. Anybody is from language, Kannada? Anybody is language, Kannada? Or any other languages, English or Hindi or Kannada? No one is from language department? Okay. So if no one is there from language department, then we take an example from the commerce. Anybody is from commerce? Anybody is from commerce?
Okay. Yes, sir. Yes, sir. There are many.
Okay. So there are many, but nobody is answering except you.
Answering.
So you are from which domain, sir?
Sir, commerce, sir. Commerce.
Oh, you are also from commerce. That I think that this example suits more appropriate for the commerce, professors. Sir, I think you might have seen, especially the commerce doing over the internet. So, which is called as an e-commerce.
Yes, sir.
Right. So, I think more or less everybody is using many e-commerce portals to do many of the businesses. Yes or no?
Yes. Yes, sir.
Right. So nowadays, everything, whatever we wanted to buy, whatever we wanted to sell, right? So most likely, we are not at least 100%, at least 50 to 60% we are dependent on these e-commerce portals.
Yes, sir.
Agree or disagree?
Yes, sir.
Right. So for example, you see Amazon, a good example that can be given is Amazon. Have you seen any Amazon shop? Right. So in any of the cities like Bangalore, Mysore, or Hubli, or Dharwad, or Bidar, any metro cities you take, Chennai, Delhi, any cities you take. Have you seen any shop, right? So which is named after Amazon?
No, sir.
No, we don't see any shops like Amazon.
Yes, sir. But physically, it does not exist. Only in online.
Yes, physically it doesn't exist, right? So, but still they are number one players. Yes. Right. So that is considered to be one of the richest, either it stands in number 2 or number 3 richest, company in the world. It's yes, just sir. Because of the e-commerce portal. Right. So it's just because of the e-commerce portal. And it does so many things, right? So, and it does so many things. It is also going to do some kind of recommendations to your purchase.
Yes, sir.
Yes, Dr. Pallavi. Dr. Pallavi, you want to tell something?
Vinata, H1.
Okay, madam is taking attendance. Okay. Right. So now if you see that, right, so it does not see, for example, a simple example I'll give you is you'll purchase something, right? So if you purchase something, right? So if you purchase a shirt, right? So if you purchase a shirt which is of brand Van Heusen, right? So immediately you will get a information saying that this particular pants, suits more to that particular shirt that you are purchasing, which is of the same brand, that is Van Heusen. Yes or no? That is nothing but an prompting, right? So you see, so so progressively, right? So this has been developed, right? So immediately it is going to respond, right? So immediately it is going to respond with the recommendations saying that this is of your interest type, right? So this is of your interest type. I think in some of the portals you might have seen, if you see any, if you see any hotel rooms that you have seen, right? So more or less in most of the recommendation systems, right? So it is going to, inform that you are interested in this kind of a data, or if you are interested in the other kind of a data. Why is that? It's all because of the recommendation system. See, these are all the different progresses that are made in the field of commerce, right? So which has made the life simple, right? So we'll sit in one place, right? So we'll sit in one place, we'll do so much of shopping. We have never ever bothered, right? So whether what type of data that we are sending, right? So we'll sit at home, immediately we'll receive the parcel, right? So we'll just see whether it suits or not. If it does not suit, even there is a return policy, and everything is done online, right? So everything is done online. Right, so without any kind of an intervention, and even in many of the cases, you will get the best discounts that you compare to the offline shopping over the online shopping. So this is one simple example. See, Amazon is one simple example, but similarly, just imagine how many number of e-commerce portals that are available in the literature or in the market, right? So in order to do this kind of a business, there are three to four different types of businesses that are done. One is business to business, which is called as a B2B. One is B2C, that is business to customer. Then customer to business. Then customer to customer. Yes or no?
Yes, sir.
Yes.
Yes. So all these four can be reasonably done to the best extent, right? So can be reasonably done to the best extent, right? So if you consider these type of data, and this is one of the application which is really leading towards which is leading towards increase in the explosion or increase in the data over the network. Now the question arises: who is generating this big data? Are the only commerce people are generating the big data? No, it is generated by everyone. It is generated by the Facebook. How many of you are having Facebook accounts? I think everyone. Yes or no?
Yes, sir. Most of them.
Most of them are having Facebook, right? So if you take a single person, at least a single person is connected to more than 100 people, right? So just imagine 1:100. Similarly, 100 is to how much, right? So then the entire network in one or the other way, then the entire world in one or the other way is totally network, right? So if I am friend to Kausar, right? So if I am friend to Dr. Kausar, then obviously Dr. Kausar is, if I am friend to Kausar and Dr. Kausar is friend to Dr. Kariguli, then obviously through Dr. Kausar, I can become a friend to Dr. Kariguli. And similarly, Dr. Kariguli is friend to some other person, right? So similarly, in that sense, I can go on increasing my, network, right? So that is one good example. We were really generating the huge data over the network. Then comes the Twitter, right? So now the Twitter has changed to X, right? So the Twitter has changed to X. Then you have an YouTube, right? So there are so many YouTube channels that exist, right? So many YouTube channels exist, and whatever you do now, there is a concept called Reels. Yes or no? Hello? Yes or no?
Yes.
Right? So Reels, right? So you'll simply prepare so many number of Reels, right? So and keep on pushing the data over the YouTube, whether you like it or not, right? So that particular data will be available, right? So then similarly we have Flickr, right? So in all we'll call it as the social media and the social networks who are responsible to generate the huge data. Then comes the scientific instruments, right? So scientific instruments like, very highly sophisticated instruments like microscope, or it could be a telescope, right? So it could be an MRI machines, it could be an CT scan imagery machines, it could be an X-ray machine, right? So there are so many different varieties of instruments that are available in the literature, right? So everything is right. So everything is connected, right? So everything is connected through one or the other forum, right? So for example, For example, now if you see our own cars, right? So most of the cars are automated, selfly automated, right? So depending upon the weather condition, automatically the headlights will turn on. Depending upon the weather condition, automatically the headlights will turn off, right? So why all these things? It's all basically the sensors which are capturing all these kind of information. Similarly, the scientific instruments, right? So we capture so many varieties of data, but ultimately at the end of the day, if we capture so much of information or so much of data, ultimately we need to have a mechanism to store this data, right? So that is why these scientific instruments will really contribute to a best extent, especially in the increase of the big data, right? So then comes the mobile devices, right? So then comes the mobile devices, right? So I think now we are so much of dependent on the mobile data. I think we can forget everything in present world, right? So, but without mobile, I think we cannot really survive. So this is a very hard, statement that I am making, right? So, but that is the fact, right? So, but that is the fact, right? So it has replaced so many things, right? So the mobile phones has replaced so many things, right? So it has replaced your time, watch, right? So it has replaced your alarm. It has replaced your music system. It has replaced, so many other things. And ultimately, at the end of the day, even it has replaced your banking system also. You need not to carry your credit card or you need not to carry your debit card, right? So it's all basically through UPI mechanisms you can do the transactions. But now the question arises whether the security, really makes a concern, right? So I don't think so, because we are very much comfortable with using either the phone pay or the Google Pay or the Paytm or any other UPI payments without giving a second thought that all your data will be secured. But still, there are many other loopholes, right? So which exist in the which exist in our day-to-day activities, and that is called as a cyber crime or cyber frauds, right? So which is another big boom, right? So in the present computer science domain, many of them are working on these domains, right? So many of them are working on these domains, right? So and it is really making a dent, right? So in the field of computer science, because when more the number of data is being generated, right? So then the data is also could be very sensitive. Once the data is very sensitive, you need to provide the highest level of confidentiality to the data also. So this highest level of confidentiality can be given, right? So by making use of the highly sophisticated security, building an highly secured algorithms, right? So this is how actually it goes, right? So next comes the sensor technology and the networks, right? So measuring all kinds of data, right? So measuring all kinds of data, sensor technology, right? So everything is sensor based and sensor connected, right? So nowadays, even at our homes, at the classrooms, right? So at the seminar halls, I'm talking about the educational institutions, right? So most of them are sensor enabled instruments that we are using, right? So sensor enabled data that we are using. A simple example, if the seminar hall is vacant for more than 5 to 10 minutes, automatically the entire lights of the seminar hall should be turned down, right? So why? Because making the statement that are thinking this are thinking that nobody is using the seminar hall, automatically the lights should be turned off. And if your machine is not turning, if your machine is not used for more than 10 minutes, automatically it has to go to the sleep mode, right? So that is also one way of a sensor, right? So now the sensor has reached to the best extent. As a good example that can be given is in even in highly sophisticated automated cars, right? So even the drivers, the activities will be monitored. Suppose if the driver is feeling sleepy, just because of his eye tracking movements, right? So just because of his eye tracking movements, right? So the car can identify whether the driver is going into a sleep mode, right? So or the driver is very attentive in driving the vehicle, right? So such kind of an highly sophisticated, right? So highly sophisticated sensors are designed and developed, right? So sensors are designed and developed, and they are giving an best, examples, right? So the progress and innovation is no longer hindered by the ability of the collected data, because you have a mechanism, right? So you have a mechanism to collect the data through different modes, right? So over the different social networks, right? So, but ultimately, the very important things that we need to really manage is that we need to really maintain is the management and management of the data, right? So management of the data, point number one, right? So the data should be very effectively managed as and whenever the required data is requested by the customer, right? So within no minute or within no seconds, that particular data has to be retrieved. Then the data has to be analyzed. So that is called as an analytics, right? So that is called as an analytics, right? So the data should be analyzed to the best extent, right? So otherwise the data analytics algorithms has to be implemented, which uses both the statistics as well as mathematics in order to do the computation and then summarize the data, right? So which we call it as a summarization process. That is nothing but you have around 10 pages of document that exist. Ultimately, it is going to generate only an one paragraph of summary of all the 10 pages, right? So, and then you have something called visualization, right? So, how to visualize the data, right? So, but the visualization comes from the different perspective, right? So, visualization comes from the different perspective, and this visualization varies from person to person. And you need to have a common interpretation for the different perception that is given by the different users. And ultimately, uh, what is the knowledge that you are supposed to discover, right? So we will call it as the knowledge or we'll call it as the information. What is the knowledge or the information that you are supposed to discover, right? So from the collected data, right? So these are the very important things that we are supposed to consider, right? So though generation of data is not an is not is no longer the hard subject, but ultimately these five components like managing, analyzing, summarizing, visualizing, and discovering plays a very, very critical role, especially in managing the big data. Right. So characteristics of big data that I already told. The first scale is volume. Right. So volume, that is we are trying to express in terms of petabytes and yobytes. Right. So that is volume. Terabytes, petabytes, exabytes, and zettabytes. And the second characteristics is the variety, right? So we have so many different types of varieties of data that are available, right? So for example, it could be a text data, it could be a numerical data, it could be an image data, it could be an audio data, it could be an video data, it could be an sequences, right? So for example, DNA sequencing or stem cells, right? So stem cells, right? So where you are going to find the series of sequence, right? So in the data, right? So then you have the time series data, right? So what is time series data? The data which keeps on changes according to the time. Then you have an social media data, right? So the data that is generated through the social networks. Then you have multi-dimensional data, right? So you have multi-dimensional data, right? So which we have already discussed in understanding what is basically a multi-dimensional data, right? So next, we are supposed to give an very interesting difference between the two types of data. One is static data versus streaming data, right? So what is static data? The data which is already acquired and stored, and you don't expect any changes in that particular data as and when the time progress. So that is called as a static data. Whereas the streaming data, right? So streaming data is nothing but you're going to capture the data, but as such, the captured data keeps on changes depending upon the time component, right? So depending upon the time component, right? So that is called as a streaming data. A good example could be your live cricket is basically a streaming data, and seeing an highlights of the same cricket match is basically an static data, right? So a single application can be generating or collecting many types of data. So this is what actually we are doing nowadays, right? So a single data, right? So a single application, right? So which considers, right? So a single applications, right? So which consider will be a single application which generates multiple number of data, right? So multiple of number types of data, right? So will gives more information. A simple example is your telephone, right? So your telephone, nowadays the highly sophisticated telephones will also capture the different types of data, like your banking data, your personalized data, your climate data, your traffic data, which can be captured through Google Maps, your traveling data, right? So everything can be captured by a single devices, right? So by a single devices, but the different forms of the data, right? So by the different forms of data, right? So this is with respect to the second complexity of the or the characteristics of the big data, and the third one is with respect to the velocity, right? So velocity, I think I've already told by taking an example of the online portal, right? So by taking the example of an online portal, right? So either it could be an Amazon data, or either it could be an Amazon, or either it could be an Google, right? So fast that the data is executed and data is analyzed, right? So that is the best part of the third important characteristics, which is called as an velocity, right? So the data is being generated fast and need to be processed fast, right? So the acquisition of the data should be also fast. The processing of the data should also be fast. The storage of data should also be fast. Whenever you want to access the stored data should also be fast. Whenever we are supposed to retrieve the data and present to the end user, even that data should also be at a very high velocity or at a very high speed, right? So this constitute the different characteristics of the big data. That is three dimensions. One is volume, right? So one is volume. Second one is the velocity. The second one is the variety, and the third one is the velocities, right? So that is what actually this particular slide presents, right? So that is the big data, which is showcasing the three V's, right? So that is volume, velocity, and the variety, right? So now, but this big data does not contain only the volume, velocity, and the variety, right? So, but it also requires three important issues that has to be handled with respect to this big data, right? So one is with respect to the transactions, right? So second one is with respect to the interactions, and the third one is with respect to the feedback, or sometimes we also call it as the observations, right? So we'll call it as the observation, right? So increasing the data variety, right? So then obviously the complexity of the data will also increases, right? So hence the transaction of the same set of the data will be very challenging. The interaction with respect to the same set of interactions with respect to and one data to another data will become more complex, and the observations, right? So there are different people who are working on the different type of transaction between the different piece of data. Then a valid feedback should also be considered in order to map between the transactions and the interactions. Right? So this is how actually the big data is characterized, right? So this is the fourth one, right? So where we have added the veracity, right? So veracity is something which is one, right? So can anybody define what is veracity? Okay, here there is a definition. Can you tell me with an example of what is the veracity? Can anybody give an example for the characteristic veracity? Dr. Manisha? Dr. Manisha? Okay.
The picture, I think it is referring to outliers in the data.
Outliers in the data? Okay. Dr. Nagamma? Okay, Dr. Saidabanu?
Yes, sir.
Anyone can answer? What is the basic meaning of the veracity?
The speed movement, sir.
That is velocity.
That is velocity.
No, sir.
That is velocity. But what is veracity?
There may be trustworthiness, some issues with the authentication of the data.
Any other answers?
The same thing, sir. Data that is available in so many varieties. Multimedia, as you told.
Ah.
That is a veracity, sir. So many varieties is called as veracity.
Okay, so that we'll call it as variety.
Ah.
What is veracity?
Ambiguity, sir.
Ambiguity. How do you got this answer?
That means it's an inappropriate one.
Huh?
Inappropriate answers.
Inappropriate answers.
Yes, sir. Inappropriate information.
You mean to say that?
Sir.
Yeah, the answer is absolutely right. Veracity is a data, right? So, which that particular piece of data will always have a doubt. That is nothing but something called fuzzy, right? So, something called fuzzy or uncertainty. There is no certainty in the data, right? So, today Chief Minister will come at 1 o'clock. Is it trustable data?
It might change, sir.
Right. So in most of the cases, they cannot come at 1 o'clock. Right. So they cannot come at 1 o'clock, sharp 1 o'clock. Right. So there is an ambiguity. He can come at 3 o'clock or he can come at 7 o'clock also in the evening. But there could be a high possibility that he can come at 1:30 only. Right. So that particular piece of data is called as a veracity of data. Right. So a data which comes with ambiguity, a data which comes with inconsistency, a data which comes with uncertainty. Right. So a data which is incomplete in its nature. Right. So is called as a veracity. Is called as the property of veracity. But that is a very hard task, especially to handle the data which comes with the veracity. Right. So because you need to come out with a mechanism. Right. So you need to come out with a mechanism such that that mechanism is responsible to handle the existing, incompleteness or the inconsistency, right? So by analyzing the data, right? So hence these 4 V's, right? So that is volume, velocity, variety, and veracity, right? So we'll make big data as more complex, right? So this I've already discussed in explaining what is structured data and the unstructured data. And there is another type of data which is also called as a semi-structured data, which is neither structured nor unstructured, and it is placed between the structured and the unstructured data. So semi-structured data, right? So this is basically a layered architecture. Why? What is the advantage of layered architecture? Or why do we want to go for layered architecture? No, is there any answer?
Sir, all users are not scientists of computers.
Okay.
That's why user-friendly some applications will be there to that extent, and research-friendly to that extent. That's why this kind of layered view is necessary.
Okay. So very trivially, how can you explain the concept of layered architecture?
Sir, the output from one layer will be input to another layer. So we have to finish one layer's work, then go to the next layer.
You're absolutely right. Okay. So it is all interconnected. If you have 10 layers, right? So layer 1, layer 2, layer 3, layer 4, layer 5. You have 10 layers and all layers are interconnected. Right. So all layers are interconnected, and the lower level will be working as a service provider to the upper layer, and the upper layer will be accepting the services that are offered by the lower layer. Right. So will be offered by the lower layer. Right. So that is why the layered architecture is more reasonably preferred. Right. So it's more reasonably preferred, and also each layers. Right. So each layers have got their own functionality. Yes or no? See, for example, in this itself, I'm showcasing three different layers. One is the application layer, and the other one is the computing layer, and the other one is the infrastructure layer. Right. So if you just see this application layer, computing layer, and the infrastructure layer, right. So there are three. Yes, there are three different, specific set of objectives are defined. Right. So for the three different types of layers. Application layer has got its own characteristics, right? So has got its own characteristics and has got its own characteristics and the way that it works. And the computing layer has got its own characteristics and its compute, depending upon the instructions that you are going to pass, right? So and then you have an infrastructure layer, right? So where it contains all ICT, right? So where it contains all ICT, that is information communication technology techniques, right? So in order to enhance the movement of the data from the lower layer to the upper layer, right? So that is why the big data, right? So always takes the layered architecture, right? So the big data always considers the layered architecture, right? So just go through this, right? So just go through this and tell me what can you understand from this diagram? Anyone? Anyone?
It's like different stages, sir. When big data is generated till the analytics phase, what are all the steps or various sources of big data generation is onto the left.
Correct.
Then various sources through which the data can be obtained, like the acquisition through sensors and some RFIDs.
Correct.
Then once that is obtained, we can store in different ways like SQL databases or NoSQL. And these days we have Google file systems, etc. And there are some other advanced techniques like MapReduce, Bigtable and all, Cassandra.
Mm-hmm.
So these are all big data analytics tools. Using that, what is the final outcome or what is the result of doing some analytics is
Correct,
there on
correct.
the right side.
You are absolutely right. So, what I request to the other participants, even though you are not from the field of computer science, you need not to worry about this diagram, right? So, especially the internal part of this diagram, but you need to worry about this timeline as and when the time progresses, right? So, the data is getting increased, right? So, as and when the data is getting increased, the horizontal line, right? So, the horizontal line which comes with the different techniques, right? So it also plays a very crucial role. As and whenever the data is increased, right? So that is obviously refers to the generation, right? So generation, the more of the data that you are going to acquire or generated, the more of the challenges lies, right? So then again, you need to have the different types of acquisition methods, right? So once the data is acquired in the different methods, you need to have a mechanism to store that huge data, right? So which undergoes the various changes, right? So which undergoes the various changes. And then lastly, you have something called the analytics, right? So where you are going to make use of the statistics and the mathematics, right? So statistics and mathematics, and you can really come to a conclusion, right? So either by prediction or classification or by clustering, right? So depending upon your requirement, given this piece of data, this is what my expected result, right? So this is how actually you are going to result, right? So especially in the big data technology stages, right? So in the big data technology stages, right? So this is what actually I explained: data acquisition, collection, transmission, and pre-processing. And then you have data storage, right? So data storage exclusively meant for managing the large scale data set, and it also maintains the hardware infrastructure as well as the data messages, right? So the data messages. And then you have data analytics, right? So in data analytics, You can do so many different types of analytics, right? So structured data analytics, and then you have text analytics, right? So text analytics, multimedia analytics, web analytics, network analytics, the mobile analytics, right? So what is basically analytics? Analytics is a concept which tries to explore the information that is, which tries to explore the information that is present in the piece of the data, right? So that is basically analytics, right? So if you see this, right, so there is an one concept which is really driving the big data to the best extent, right? So to the best extent. So if you plot the business value versus the complexity value on the left hand side and the right hand side, right? So there are so many things that really encountered, right? So by any engineer, right? So by any engineer who are working on this, right? So more or less the predictive models will play a very crucial role, right? So will play a very crucial role, especially in handling the big data, because optimization comes into picture, prediction analysis comes into picture, complex statistical analysis comes into picture, all types of data and memory sources comes into picture, right? So more or less, very importantly, all the data that are communicated will pass through these systems only through, right? So only through the real time, right? So real time algorithms that we are going to build. So real time algorithms are the set of algorithms or set of instructions which follows depending upon the instructions that you are going to give, right? So instructions that you are going to give. Hence, this is where actually we need to concentrate, right? So rather than this stage or this stage, right? So this stage or the above stage, right? So now we are slowly into the edge of this mid particular mid space, right? So that is almost slightly above the edge, right? So this is what actually we stand, right? So this is where actually we stand in the present day, especially to do the predictions of whatever the data that you are going to consider. But as we think, the prediction itself is not an easy task, right? So again, the prediction depends upon the various internal and the external characters, right? So value of big data. And where can you see the applications? You can see the applications in almost all the industries. Smart healthcare, right? So homeland security, traffic controller, manufacturing, search quality, trading analytics, telecom, medals, multi channel sales, right? So etc. Right. So all these domains in one or the other way, it contains the data, right? So it contains the data, right? So these are some of the applications of the big data. Okay. Challenges of handling the big data. So one is the technology itself is a bottleneck, right? So we don't have an highly sophisticated technology, especially to handle such a huge huge rate of data. That's the very challenging problem. And also in technical skills, experts in using the new technology and dealing with big data, right? So this also really requires a lot of attention, right? So to be given a lot of attention to be given, especially to come out with whatever the challenges that we are going to face, right? So especially in terms of technicality, right? So to handle the big data, right? So these are some of the challenges, right? So these are some of the challenges, right? So the last question that I wanted to give is, what technology do we have for big data, right? So that's the biggest question mark, right? So the first and foremost thing is saying that data itself is a big is very challenging. Then identify. Sorry, anybody wants to tell? Okay. Right. So each and every day the technology is growing like anything. Right. So the technology is going like the growing like anything. Right. So but ultimately for tomorrow's question, what technology do we have for big data? So that is the biggest question mark that we are leaving. And these are some of the technologies that exist in 2012, right? So especially to handle the big data. But if you see in 2023, there are some more additional, technologies, right? So additional technologies, right? So that are added, right? So during the year 2023, right? So this is the same as there are so many, additional technologies that are available. But you decide depending upon what type of data that you are going to use and how this data can be used to your domain, right? So and how the data can be used for your domain. Either it could be commerce domain, education domain, etc. Right? So this is also called as an explosion of technologies in the area in the year 2023. Right. So this is the moving parts. And these are some of the references book that I wanted to give you all. Right. So especially in order to understand the big data, I think I don't really understand, recommend this Hadoop or Hadoop glossary, the title book of big data or handbook of action. Right. So I strongly recommend to go with uh, mining of massive data streams one, right? So mining of the massive data streams one, right? So which is written by Ullman, and you can go with any fundamentals of multimedia, fundamentals of big data analytics, the book written by the RLD publishers, right? So I think they are the best models or the books that can be made available. And ultimately, what is the inference that you can draw in this image? Can anyone tell what is the inference that you can draw?
The big elephant is helping the small elephant to go to the top levels by kneeling down.
Okay.
Helping to go to the heights.
Okay. Then any other answers? Any other answers? Okay, if no other answers, this is the answer. Big data isn't big. If you know how to use it, I think that is more than enough. It's not a big deal, right? So that we should, feel that, we are trying to handle the huge data to the, corest to the core, right? So, but only thing is, if you know the mechanism, right? So to handle the data which is considered to be a big, I think you can use very effectively the big data, right? So, any questions till now with respect to big data? Huh? Any questions now? Any questions till now? So is it all clear that how this big data can be applied to your domain?
Today, actually, we had more interaction in compared to all other sessions.
Okay.
That's why there may not be questions, because it was completely interactive session.
Okay.
From last session also continuously we were discussing now, sir.
Yes, sir. Yes, sir.
So
I think this kind of an intersection, if you open up, especially the problems that you are facing in your domain, right? So maybe we can give some solutions which really makes more which really makes more meaningful and can be used to your area of research, right? So fine. So if this session is fine, maybe I'll just try to share some slides on cloud computing. Hardly I may take another 5 to 10 minutes of time, right? So just to showcase what is basically a cloud and how these big data and cloud are interconnected. Okay, is it okay with that? Please tell me once the slide is shared.
Okay.
Yes, sir.
Okay, so are the slides are visible?
Yes, sir.
Okay, so we don't really worry. Please forget about this, sir. We don't do any computing, right? So in this session, right? So we don't do any computing because computing itself is a very challenging task. We'll just try to understand what is basically a cloud and how this cloud can be used to our education and day-to-day education and takes the benefits of cloud and cloud technology. This is the outline. Right, so understanding cloud, I'll just skip all these things which are very fundamentals. Right, so okay. So first we need to understand what are the main jobs of the computers. Right, so the main jobs of the computer is need performance to handle the amount of data. And in the meantime, you need to have a high resolution, high quality, and the complexity of the data should also be in a position to be handled. Right. So these are the main requirements. Right. So that is needed, especially to make use of the computer technology. Then we have something called growing demand, right? So more online users every day, the users, right? So who are called as an online users, right? So are increasing over the internet. Similarly, applications, right? So every day, every minute, every now and then, right? So there are many applications that are running into the market, right? So but how to manage these things, right? So specifically, right? So that is what actually we need to do, right? So as we said, the data is in terms of huge, that is in terms of volume, in terms of velocity, in terms of variety, but how to how to handle this, right? So how to handle this itself is a big challenging task, right? So hence, in order to give a solution for this, one of the most widely available solution that exists in the literature is cloud. I'm sorry. Okay, so cloud computing. So web scale problems. See how many number of web pages are there in the present internet, right? So it's just unimaginable, right? So there are more than billions of web pages are there, right? So large data centers, right? So different models of computing and highly interactive web applications, right? So, but ultimately, in order to accommodate all these things, right? So what do we need? We need the highly sophisticated machines, right? So we need a highly sophisticated platforms to handle this kind of a data and highly sophisticated services, right? So to take care of these services. Hence, in order to achieve this, right? So we have a concept called cloud computing, right? So and the definition of the cloud computing goes like this, right? So it is a type of internet-based computing, right? So where different services such as servers, storage, and applications are delivered to an organization, computers, and devices through the internet. Right. So, hence, this clearly says that is the usage of the cloud says that, right. So, you need not to go for any purchase of servers. You need not to go for any purchase of hard disk, right? So, which primarily used for the storage, and you need not to go for any specific applications that can be installed for any given organization, right? So for any given organization, right? So that is why this cloud computing technique is used. So advantages of cloud computing is used, right? So basically, basically the entire cloud architectures looks like this. So we all sit here, right? So we all sit here, right? So there are two clouds, right? So there are two clouds which are maintained, right? So at the different levels, right? So at the different levels, right? So which provides the service to the best extent, right? So what are the common characteristics, right? So especially with respect to the cloud computing, one is the massive scale, right? So massive scalability of the data. Then comes the homogeneity, right? So homogeneity means we are trying to push the same set of data, which is not acceptable. Then we have something called the virtualization, right? So virtualization means the physically does not exist, but logically exists. And you need to have the low cost software, right? So you are not ready to spend so much of amount, especially for the purchase of the software. And then geographic distribution, service orientation, and advanced security. These are some of the common characteristics that we are supposed to expect by any cloud computing architecture. Otherwise, essential characteristics: on-demand self-services. Whenever we need any service, right? So the cloud should be in a position to offer that kind of a service, right? So in a very interactive way. So then we have a broad area network which can be accessible. Right. So then rapid elasticity, resource pooling, right? So such that no given piece of data, right? So will be used for the multiple purposes, and that particular piece of data is exclusively dedicated to handle to that particular application itself. Right. So these are some of the common characteristics of the data. That is common characteristics and essential characteristics. Okay, so with this, the three different types of services, right? So that can be expected by the cloud service model. So you need not to purchase any computing machine or any operating system or in any platform for the different operations of your requirement. Rather, you can make use of only the cloud that is available by making a very nominal charges. Basically, they present the three different types of services. One is SaaS, that is software as a service, right? So if you want to purchase, if you want to make use of the Microsoft, you need not to pay an FT amount for the license of the Microsoft. So what we can do, you can just pay a very nominal fees to the cloud service provider, and you can use that Microsoft software, right? So for your service. Once that service is exhausted, either you can go for renewal of that particular service, or you can terminate it, right? So we can terminate it, right? So the second one is the platform as a service, right? So where you have the various platforms, right? So various platforms, like it could be on Windows, it could be on Macintosh, it could be on Linux platform. Right? So there are so many different types of software, platforms that are available, right? So you need not to keep on installing the new platforms as you wish, right? So hence, what best you can do, you can just log in your laptop to the cloud services, and you can take to use any required platform, right? So for your service. And lastly, the infrastructure, right? So infrastructure is totally ruled out. Many of the schools and colleges have stopped investing, or any application or any vendors have stopped, investing on this purchase of the infrastructure, but rather they'll just simply, take the cloud services, right? So they'll simply take the cloud services, such that the infrastructure can also be considered as the third service that is offered by the cloud. Right. So overall, the three types of services: service as a software, SaaS; platform as a software, PaaS; and then IaaS, that is infrastructure as a service. Right. So these are the three different services that are offered by the cloud service. Right. So then we'll directly go to the education field, that how this is going to help us, especially in the education. Okay, so some of the benefits, right? So some of the benefits of using the cloud in the education field is simplifying admissions, right? So because you need not to have a separate server, separate storage in order to maintain the student basis, student databases, right? So you can just simply go on posting in the cloud, right? So go on posting in the cloud, and then you have an admission process, right? So where you can sit anywhere else, right? So and you can take the admission to the university. And then you have the infrastructure outsourcing, right? So where you need not to purchase any infrastructure that is required for your domain, you can make use of the cloud, right? So to take the infrastructure as a service for your research work or for your domain. And then you have minimum hardware investment, right? So I don't think so that is a minimum hardware, right? So no hardware itself, right? So hardly you need an one computing machine, right? So in order to exchange the information between the cloud, right? So and the application, right? So and the application and minimum critical application, right? So minimum critical, try to keep as many as much as minimum, especially the critical applications that we are going to encounter, right? So these are some of the benefits that we can find, especially if we apply the cloud, right? So over the higher education field, right? So some of the benefits: access to the application from anywhere, support for teaching and learning, software free or pay per user, right? So 24 hours access to the infrastructure and content, opening to business environment and advanced research, and then protection of the environment by using the green technologies, increased openness of students to new technologies, increasing functional capabilities, and lastly, offline usage with the further synchronization opportunities. Right? So these are some of the very interesting advantages, right? So are the benefits, right? So that are given by the cloud, especially in the domain of the education, right? So especially in the domain of education. Right. So classrooms in the end, if you see, right, so you have mobile learning, you have online academic and open education platforms, you have foreign language learning, right? So you have foreign language learning, right? So especially if you want to use the mobile learning, right? So now the people are coming with a new concept, right? So maybe another down the line 2 years or 3 years. Right, so people, the UGC itself or the government of India will recommend, right? So for the education system in the form of an BOYD, right? So that is BOYD, right? So BOYD, right? So BYOD, right? So what is BYOD? Bring your own devices, right? So bring your own device, right? So what is bring your own device? Maybe you can carry your mobile phone to attend the class, take notes, write an assignment, and submit the assignment. So this is the next future classrooms that we are going to encounter. Right. So now we have already given the attention towards the mobile learning, right? So which is going to the best extent, and some of the very interesting benefits like student engagements, resource availability, and simplification of TLP, that is teaching and learning processes, right? So I have improved to the best extent, right? So by allowing the mobile phones or by allowing the mobile devices to be used in the classrooms, right? So now everybody is using something called the MOOCs or the Swayam, right? So MOOCs are Swayam portals, right? So which is a platform which provides the various educational courses that are offered, right? So with a very nominal price, right? So the entire service is offered through the cloud. So that is why so much of so much of security is given for such kind of an online classes, right? So that is where actually you can use the cloud, right? So last you can use to learn the foreign language also, right? So we have the various committees like Live Mocha, Share Talk, Language Exchange Community, right? So otherwise you can make use of simple apps, mobile apps, right? So simple mobile apps are the social networks, right? So to really look for how the language learning can be taken into the next level, right? So this is what it thought that the government of India is giving, especially in exploring the content that is present in the cloud, right? So especially the content that is present in the code. But more or less, it's all plug and play, right? So you can play any content, right? So according to your requirement. But only thing is, there will be a very nominal charges, right? So where you will be charged at the nominal price, right? So for attending or for delivering some of the contents over the cloud, right? So these are some of the applications. So any doubts till now, especially with this? So we have various service providers for the cloud. We have Microsoft, right? So we have Microsoft, and then we have Google Apps. I think you might have seen this Google Classroom and all, right? So Google Apps for education, Microsoft for education, Google Apps like Google Classroom, Google Meet, right? So Google Meet, right? So Google Slide Maker, right? So all this can be used especially in the educational sector, right? So then we have the Amazon AWS, that is Amazon Web Service in education, right? So where you can store the resources to the huge, right? So to the huge, and you can attend and participate in the various classes that are conducted, which are made available in the Amazon cloud, right? So these are services, some of the services that are offered by the three giants. One is Microsoft, the second one is Google, and the third one is the Amazon, right? So they are the three major, they are the three major contributors, right? So especially to implement, right? So especially to implement the various cloud services that are offered, right? So to explore the various cloud services that are offered, right? So in summary, just to summarize, we started with the big data, right? So we started with the big data, and then we just define what are the various characteristics of the big data. Then we defined how this big data can be handled to the best extent. What are the different characteristics of the big data, and the layered architecture of the big data. We took some of the applications also for the big data, and then we saw that how these cloud can be integrated with respect to the big data, because especially from the perspective of storing of the data by the big data, right? So then obviously it should be in cloud, right? So obviously it should be in cloud, right? So hence the cloud and the big data are interlinked. And lastly, we saw some of the fundamental applications of this big data and these cloud services to the field of education, right? So to the field of education, right? So any doubts, I can take your questions now. Any doubts? Any doubts, any clarification you require? Okay, I think either it should be two things, either fully understood or not understood anything.
It's actually really
Understood,
informative
sir.
session, sir. Live interaction.
Okay, okay.
We
So
have learned a lot.
I really express.
Non-technical. Sir, actually, we are non-technical background, even though we have understood so many things, sir.
Yeah, that is very important, sir. Thank you so much for your words.
Thank you, sir.
Okay, so if there are no questions, so once again, I take this opportunity to thank everyone for your patience listening. So hopefully we'll physically meet sometime at Mysore in the HRDC center. But that's a beautiful campus. You should really visit. So we can engage the physical classes very shortly. Once the UGC opens the gates for the offline classes or the physical classes. And with this information, I also would like to thank Dr. Nanjan Swami sir and the director of the HRDC for giving me this opportunity to share some of my experience, right? So to share some of my experience. So I wholeheartedly thank everyone for patiently attending, and hope it was resourceful for you all to apply the concept of big data and cloud to your own domain. Thank you very much, sir. Thank you very much.
So on behalf of HRDC and participants, we immensely give our heartfelt thanks to you. Even though we are from non-technical background, it was very convincing and we learned a lot by you, sir. Thank you once again, sir.
Thank you, madam. Thank you, madam. Thank you so much.
Yes,
you,
yes, sir. Thank you so much. Very
Thank you,
informative,
madam.
sir.
Thank you, madam. Thank you so much.